part to the continuation, and I'd asked what does negative 4.20 times 10 to the negative 19 joules means in this change in electric potential energy. We have the negative. What does that negative sign tell us? The negative really just indicates, shorthand notation for negative, indicates that the electric field loses potential energy. And it is losing this potential energy by doing work on the proton. So that's part A, calculating the change in electric potential energy. And we remember that this proton moved from rest. So let's see what this is going to tell us. We are able to calculate, using the law of conservation of energy, the speed of the proton at the final position. And remembering from the last example, we do have the change in position as 1.5 meters. We have our field strength as 1.75 newtons per coulomb. We have the charge of 1.60 times 10 to the negative 19 coulombs. We do need the mass in this case because we're going to use conservation of energy. And the mass of a proton is 1.67 times 10 to the negative 27 kilograms, and we need to figure out the speed. Because we have the law of conservation of energy, we have electric potential energy that is being converted into kinetic energy in this case. And it must equal 0 because no energy is lost or destroyed, or created or destroyed. So we're assuming, because of the law of conservation of energy, that this should be 0. Solving for EK, we get that kinetic energy is equal to negative EE. And I'm going to keep the electric potential energy as it is just for one moment, because we know that our kinetic energy is 1/2 mv squared. And because I'm calculating V, it is simply going to be 2 multiplied by negative EE, so we have negative 2 delta EE, all over our mass, and we will square root that. Multiplied by 2 because 2 is a fraction here. We're dividing by our mass because we need to isolate for V. So therefore, this will be negative 2 times negative 4.2 times 10 to the negative 19, all over the mass of 1.67 times 10 to the negative 27. And we need to calculate this right now, which I'm punching into my calculator quickly at the moment. And we get an answer, 22,427.528. And again, 3 significant digits in this case. So our proton has accelerated to a speed from rest of 2.24 times 10 to the 4 meters per second at the final position. I hope that makes sense. That's all for today's lesson, and you'll be given your questions that I'm wanting you to complete with the video as well.